1976 Dentside Ford F250. Gonna help a young man figure this out. It's got a battery drain. Doesn't seem to be idling very well either, so we'll look at that. Sounds good. Give it a few revs. Oh yeah. A little more. Alright, let it idle. Okay, I'm gonna hand the young man the camera. He's gonna operate the camera and tell us a little about his truck. Okay, shut it off. I'm going to capture the noise that's coming from the battery right now. It's boiling. So we might have a charging system fault. He said he's gone through 3 batteries thus far, so I'm going to hand him the camera and let him talk about his truck now. Alright, young man, tell me about your truck. What year is it? What kind of truck is it? What's going on with it?
It's a 76 F250 Highboy with a 390, and my battery keeps dying, so I have a drain somewhere.
Okay, and when you park, you have to basically disconnect the battery every time, right?
Pretty much, yeah, unless I know it's not going to take too long.
Yeah, and you added some lights. There might be some add-on wiring we might need to look at. The battery's actually boiling right now because he just got here, just parked, and I can hear the battery sizzling, so something's up with that. How many batteries have you gone through in the last few months?
This is the 3rd battery.
3rd battery, and it looks new.
May.
Yeah, so it's eating up batteries, and that could entirely be because it keeps going dead over and over again, or because I can hear it sizzling, it could be overcharging. Come over here and point things out. So show me what you got to do. You got to disconnect the battery.
Well, usually I just take the positive off and let it sit, and then it doesn't drain. I've added this wire for a phone charger, and this little one is cab lights, but neither of those have done anything.
Okay, I don't see a fuse. I would recommend a fuse on both of these wires.
There's a fuse in the cab.
Well, I'll tell you this: the fuse, when you add something to the positive side of the battery, you should have a fuse within 12 inches of the power supply, because say if this wire rubs through right here and touches ground, it's going to burn your truck to the ground, because the fuse is after that. Make sense?
Okay.
So I would recommend relocating the fuse to the source. So that's something we may have to address. And also, you said something about the power steering. What's going on with the power steering?
It's been leaking, so I got sick of refilling it and just took it all off.
Yeah, why don't you get in there and show everyone what's going on with the power steering. What did you do?
I just bought a new bracket for it. It doesn't quite line up. I think it's bent, but
Yep, it looks bent to me.
So
or it's missing, or it could be missing a supporting bracket to the back or something.
Yeah.
It looks bent, but
Oh yeah.
I need to bend that back, reseal everything, and buy a belt for it.
yeah, you said so. So you said the pump is leaking.
Oh yeah.
Yeah,
And that's
so the
just a
pump's
cheap
leaking.
pump that I put on it.
So it's kind of hard to steer. Doesn't quite idle right. Could maybe use some adjustment
Is
to
it
tune
leaking
up.
down below at the box itself?
Well, right now I see a bunch of fluid that looks like it's spilling out of the pump and down onto the box, but we don't know.
I'm not sure what's leaking. It drips from everywhere.
So 1976 Dentside, battery's going dead. Young man here says that he disconnects the battery. That's what I'm going to do here. And the key's off, right? So
Yep.
the key's off. Everything is off. I've got a test light here, 12-volt test light. Come on in a little closer. I'm going to self-test my test light, verify that the test light is working. I'm going to connect the test light to the battery positive that is disconnected. And I'm going to connect to the battery positive, and as you can see, the light is lit. So this is kind of an old school method to prove that there is a key off draw somewhere, and I'll give you my thoughts on that in a second. But there's a few methods you could use to do this. You could use a voltmeter in the same way, although I prefer to use a test light, because if the light is lit, it is actually drawing enough current to light the light. You could use an ammeter, but we don't know just how much current is flowing, so you could blow the fuse in your ammeter. You might want to avoid that until you know what's really going on. Another thing to note is that when we reconnect the battery, there's a spark or an arc. And you probably can't see that on the camera. Maybe come in and get this angle. See if you can get that over here. Get up close. Right on top of that thing. So I'm going to reconnect the battery, and you can see that little arc and a spark. Okay, so definitely we got a current draw of some sort. Okay, so young man here mentioned that he added some lights and he added a phone charger. So when diagnosing this battery drain, it might be a good idea to take those completely out of the picture. So I think I'm going to remove these temporarily, and like I said, we want to add a fuse to these for safety, otherwise your truck will burn down. You got a 1/2-inch wrench?
Yes, I do.
Okay, so we're going to get the 1/2-inch wrench and unscrew that real quick and take these off and see if the problem goes away. Come in here for a little more detail. Now, one other thing that I noticed is that you added this little alligator clip, which looks like it goes all the way over here to the automatic choke. So this could entirely be your whole problem, because this on your automatic choke is actually supposed to be connected to key on. That makes sense? So that means that your automatic choke is receiving power non-stop, continuously, okay? That might be your entire problem. You never know what you're going to find when you're working on cars and trucks. And just to test that theory, I'm going to do the old test light method and just disconnect that. And as you can see, there's still a key off draw, so it's not entirely the automatic choke, but that's just one thing on the list that needs to be addressed. Okay, so now I'm going to take the add-on accessories off. Now come on in here and get some detail of what I'm doing. 1/2-inch wrench. Always rule out the customer-induced items first. So theoretically, everything that has been done to this truck is removed. We don't actually know what's all been done, because you know, it's an old truck. It's an old truck. Somebody might have done some mods to this truck that he doesn't even know about. As you can see, still has a draw. So at this point, perhaps we need to go poking around under the dash for anything else we haven't noticed as far as add-on wiring. And of course, there's also something tapped in here. You know what this is? It's actually, this almost looks factory fusible link, right? So this looks like it's a OEM wiring. Another possibility is a shorted alternator. I've seen that. So it could be additional add-on accessories we don't know about. Could be a could be a shorted alternator. I've seen that several times. May need to go to the fuse panel and start removing fuses, or review the wiring schematic. Being in 1976, wiring schematics shouldn't be too hard to come up with, but in the case that we don't have the wiring schematic, we're just going to have to use some logic here and start removing fuses or something else like that. Might need to use the wiring schematic, start removing fuses, disconnecting the alternator, just see what makes that draw go away. Okay, come on in here. I did a little more poking around. I do believe that this fuse link goes to the alternator, so probably a good idea to disconnect this. Hopefully these corroded terminals don't snap off when I do that. So that would quickly rule out the alternator. Voltage regulator here, you said, is new, correct?
Yes.
So new voltage regulator. This needs to be grounded, just so you know. So this needs to be actually bolted down tight with a good ground back to the negative battery. And this may or may not be a good ground because of age, and there could be a million ground straps that are disconnected, corroded, broken, whatever. So this needs to actually be grounded. I'm not sure where this is actually supposed to mount on this truck. I know that on the bump side it mounts right there. On the bump side it mounts about right there, and we'll make this into a bump side video as well. There's the set 1972 bump side. If you want to see where the voltage regulator mounts on that, we'll go take a look real quick, but that's not the focus of what we're doing today.
Check that
And this also needs to be tight. Have you ever had trouble with the starter not working?
Not really.
Okay, well this solenoid also needs to be tight.
Pretty sure those are the wrong screws for it.
Or it's either that or the holes are completely done and wiped out. Don't be surprised if it doesn't start now or the starter doesn't work because we tampered with this. Like I said, this does need to be grounded to operate properly. And this fuse blank might actually go to a lot of other different things, because all I'm seeing here, this is the B plus stud, battery positive stud for the starter solenoid, which goes straight to the battery. So this fuse link actually probably goes to basically the whole entire truck. And but it does look like it branches off down here. It's a kind of a mess of wiring that we might have to decipher, but it does seem to branch off down here to the generator, which would make sense that the generator has to be connected to the positive battery side of the starter solenoid. See, either the draw has gone away because I removed that fuse link, or perhaps because that starter solenoid's loose. But let's see. Let me connect from this fuse link to the battery positive, and as you can see, the light is lit, so that kind of proves that the current is flowing through the fuse link. That's almost obvious if you really know how these are wired up, but that's the point of this video, not everyone knows. Okay, so because this branches off, come on in here, get a little more detail on the wiring. So this is a mess of wiring. This fuse link goes to this nice thick cable. There's one little red wire that branches off. Perhaps I can disconnect that, but I think I want to take a look at the wiring schematic. Because this branches off to the alternator, I think I may have to actually disconnect the alternator B plus stud on the back of it to rule that out. And I don't know if you can hear that. The battery is still boiling, still cooking, so I don't think your battery is going to last very long. So at this point, I'm going to take a look at the wiring schematic and kind of get a feel for things and come up with a plan for next steps. Alright, so I took a quick look at the wiring schematic. We don't have a functional printer at this time, so perhaps I'll have to add that in later because it's a big mess to look at. Come on in here. So this fuse link, and as you can see, I added the vice grips to hold the test light in place, and I've got the test light connected to the fuse link. It is lit, so we have current flow of some sort. And I traced this fuse link down to the alternator, which this might be hard to see on the camera, but it goes all the way down here, loops back through here, and then down here branches off. There's a little Y splitter branch right here, so this right here goes back to the truck to power everything else, and as you can see, that branch goes to the back of the alternator right here. So just to rule out the alternator quickly, I'm going to disconnect it carefully because you don't want to short anything out. I'm going to disconnect that battery positive stud on the back of the alternator. Like I said, I've seen that multiple times, a shorted alternator, blown diodes or whatever, and it's a shame. Now back up, get the test light in there at the same time. Okay, I'm going to disconnect the alternator. We'll see if the light goes out. The light did not go out, so show that I disconnected it here. Can you see that? Okay, I disconnected the stud on the back of the alternator. The light did not go out, so that means that the problem is further down the line. The battery drain is further down the line on one of these branches, and there's a couple of connectors in here too. So like I said, it branches back to the truck. So like I said, it branches back and comes back here to send power out to the rest of the truck. Now what happens if I disconnect this super duper crusty connector that's stuck? Still drawing, okay? So let me figure out what connector this is, what we have disconnected and what we have not disconnected. I'm gonna go take a look at that wiring schematic again and get my bearings. It's kind of hard to keep track of all this because there's a big bundle of wiring under the hood. Okay, give me a minute and we will be back. All right, so I spent some time doing a little bit of research. I did some poking around off camera. I decided that I want to quantify how much current draw is flowing. I brought out the DVOM, digital volt ohm meter, multimeter, automotive multimeter, whatever. As you can see, the connections are going for measuring an amperage draw. So as you can see, I've got the test light connected to battery positive. The current is flowing through the wire of the test light, and it is connected through the meter, going back out the meter all the way to battery negative. And this is kind of backwards. I should have my leads the other way around, but it really doesn't matter. The number's going to be the same. Get a view of the meter here. It says we've got approximately 300 milliamps or 0.3 amps. Just the light by itself draws about 300 milliamps, which is not a lot. It means that a very small current draw will light this light. So I decided I want to rule out, is the light just a little too sensitive on this draw? Okay, so let me reconnect some things here. Now I want to connect from the meter. So I'm going from battery negative, goes through the meter, through this lead, and I should actually have this the other way around. But like I said, it doesn't matter. Come on in and show that it doesn't matter. Look, I just switched the leads around. So I switched up the leads. We're going from battery positive through the light, connects to the meter. This red wire goes through the meter, goes back out the meter, and my meter just timed out. Goes back out the meter to battery negative, and the number's the same. It's just previously it was a negative number. Now, can you see that number? Okay, it's literally the same measurement. It's just now it does not read in negative values. So now what I want to do is measure how much current draw does the truck actually have. Okay, I've moved some things around. We're going to measure the actual current draw on the truck. I've got the red lead connected to battery positive, going through the meter, measuring amps, going back out the meter on this wire, and I'm going to touch the fuse link that we know the problem is on that fuse link. And if you see what the meter reads right there, come on in here. It says about 1.8 amps, and that will definitely kill the battery overnight, if not in half of a day. This would probably kill your battery in half of a day, if not overnight. Okay. So from here, I'm going to cheat a little bit. I'm going to bring out the fancy tools, and because I don't want to be cutting wires, and there's a lot of connectors that I can't disconnect because they branch off together. And we're going to hone in on where this draw is coming from. Alright, we did a couple of electronics lessons with the young man here. He asked some questions. So we rearranged some things. I still got the ammeter here, measuring about 0.26, 0.27. And if you look at how I've got this connected, I've got, so obviously the light is lit. We have current. I have the negative lead on the meter connected to battery positive, going through the meter on amps setting, going back out the meter to this red lead, connected to the test light, and then the test light is connected to that fusible link. Okay, so the test light is connected in series with the draw. The truck by itself has a 1.8 amp draw. I know that the test light itself by itself draws about 300 milliamps, and when I tried to connect them in parallel, the light just wouldn't stay lit. And I wanted to have the light lit so we could have a visual indicator when we do find the draw. We're cheating a little today because I've got the inductive ammeter, and the reason for that is because I don't want to be cutting wires and disconnecting things. And if you think that you can't use one of these, you can. They're pretty cheap on Amazon or other such sites, and you can get them that connect directly to a voltmeter. So you can definitely use one of these at home with a little bit of knowledge. They're not hard to use. And I've got the inductive ammeter connected to the top-down Phoenix scope, and we've got the screen down here. And I can show you, I could overlay that footage on the screen if needed. So I know on this voltmeter, or ammeter at this time, I know on this ammeter we're measuring about 0.27 or 300 milliamps, 0.3 of an amp. And if I clamp in line with that, you can see that on the scope, approximately 300 milliamps. So the scope is picking up. Now come on in here and show what I'm doing. And I can now essentially clamp around each wire and get a measurement. Oop, backwards. So now I can just show what I'm doing, and I can overlay that later. So now I can clamp on over each wire in this branch, and I can determine where is the current flowing. And I do have this main line, this main connector here disconnected, which didn't make any difference, so it's not that. And I did mention before that I thought it was the alternator. Okay, so I'm clamping over the main feed. I'm getting the 300 milliamps. I'm going to clamp over this one, and I've got not 300, and it branches off to this red wire, nothing. And if I clamp over this yellow wire here, we are seeing the 300 milliamp draw. Now, if I follow this yellow wire in this big bundle of twisted up wires here, that yellow wire goes here. Where else does it go? It goes... This is a big bundled up mess of wire. Okay, so it goes here. This is the other end of that yellow wire. Goes magically over to the voltmeter, or the volt regulator. So this yellow wire that it has the draw, let me confirm that. I can clamp over that yellow wire, and we are seeing the draw. Now zoom out a little. As you can see, I have the inductive ammeter clamped over that yellow wire that we traced from there all the way to there. And when I disconnect this voltage regulator, watch that test light. Can you see everything? Yep, see that test light? Okay. So when I disconnect this voltage regulator, that light's probably going to go out and our draw is going to disappear. And it did. So that proves that at least the problem is related to our charging circuit, and that would probably answer a lot of questions as far as why is the battery boiling. Like I said, I thought it was probably caused by a faulty alternator or some sort of electrical problem with the charging circuit or charging system. And this was a brand new regulator, right?
Yes. Brand
new regulator, didn't change a thing. But as you can see, when I plug that back in, the light is lit and the draw comes back. So this could potentially still be a faulty alternator, shorted alternator. And I can't really get to the wires down there, which is another reason why I decided to use the inductive ammeters, because I can't get to the wires on the back of that alternator without starting to take things apart. So I think what we need to do from here is get to the back of the alternator, or again, take a look at the wiring schematic and see if there's anything else going on. I can't remember how these are wired up. It's been a while since I've messed with one of these. I can't remember if there has to be key on or off for anything to happen on the alternator. I'll have to verify that or not. So, okay, so we narrowed it down to the charging system, or at least there's a draw that goes away when I disconnected the voltage regulator. And I will have to take a look at the wiring schematic and verify that the alternator does not need key on or off or anything like that. And if needed, we'll be taking the alternator off, and we probably actually have a donor alternator we could throw on there and test real quick somewhere around here in the Cave of Wonders. Okay, stand by. We will be back. Alright, they're taking a look at that power steering bracket real quick. I was doing a little research on the voltage regulator thing. So this truck does not use the I terminal, which would go to your ignition switch. It uses the A terminal, the S terminal, and the F terminal. So the A terminal on the yellow wire is your voltage sensing wire. The S terminal goes to the alternator stator, and the F terminal goes to the stator. So it would appear that this is most likely a faulty alternator or blown diodes or whatever, which you could take this thing apart and repair it. What I think we need to do is take this alternator off and swap it with another one, which I'm sure we have another one out around here, and just see what happens, and we'll get back to it.
Okay, tighten it up and we'll see how the brackets look. There you go. Just snug, it doesn't have to be super tight so I can get a straight edge on it. Okay, but I see something wrong. Where is it hitting? Okay, tighten up the bottom one.
So what are we doing here? It was less time and effort to just take a donor alternator off the 1969.
Yes.
I'm sure the connections are all the same. The wiring, I think, is the same.
Oh, look at this. Yeah.
And since this is the bump side that I mentioned earlier, there's where the voltage regulator goes on the bump side. I do believe on the 1976 Dentside here, the voltage regulator is also supposed to go in that same location. And the young man did mention that there's a bolt there for it, so we might have to relocate it because this needs to be grounded anyway.
I have 2 new bolts for it. 2-finger doning, if that's about that.
Yeah, makes sense.
Got the battery disconnected so that he doesn't lose any fingers today. Young man is taking off the alternator on the 1976 Dentside. We are going to take off the test alternator from the 1969 Bumpside F250 and see what happens. Stand by. Alternators don't like when you bash on them, it breaks things inside of them. Good thing we... Oh, you know what? Before we did that, I wanted to do the fancy test with the oscilloscope, but I guess it's too late now.
What's that?
Well, I wanted to do the diode test with the oscilloscope, check voltage and amperage pattern, but I'm sure that we're going to be putting this back on later, so I think we can do that afterwards.
Yes, disconnected the battery, making sure the negative cable. Guess I could have hooked up the air ratchets and all that, but I didn't feel like it.
Where's your ratchet? No socket and ratchet wrench?
No, this bolt's bigger than the other one.
Yeah, we got sockets. What do we got? That looks like a 5/8 or 3/4.
5/8.
Yeah, let's get the socket wrench in action. 3/4. I would prefer 6-point, but you have the ratchet, or we only have one ratchet? Okay, let's see if this is the right size. What is it? 3/4? No, that's too big. 5/8. 5/8. Here, try that. 5/8 socket. Does that fit?
Yep.
Perfect. There you go. That made it easier. Is that a good spot for the light, or is it blinding you?
No, that's fine.
Perfect. I don't know. We got to get the other one off first.
I guess I'm too fast, huh?
That's all right.
Maybe pop those out.
Looks similar to me.
Okay. A good old Leatherman get me through the day every day. Save every little nut and bolt.
Well, of course, these are threaded, and on his, they're not threaded, they're slip-on. But
slip right onto the stud.
yeah, that's right, it'll go over the stud.
And most people forget this right here. They're ground. Right there. Remember, sometimes the wires get broken there, they never put the ground back on there. It's amazing. Okay, that's going to be a 3/8. It's going to be 7/16. 3/8 will be socket.
Okay, what's the back of this one look like? It looks pretty similar to me. I'll have to get it off of there. I'll bring it up here. Will it prop up real quick? Here.
That ground wire is blocking it. Ground wire. Maybe.
Okay, just flip it up right there. And we will see if they're interchangeable. Which I'm sure that we could make it work, but how much modification do we really want to do today on something that we're going to put right back on? That looks like the ground stud. I believe that goes through the wiring harness. That's the B+. This is, they're labeled. That's the S terminal, stator terminal. So this would be the F terminal, the field terminal. Right. Okay, I'll let you guys do that. Give us a second here. Hopefully this is going to be interchangeable for a quick test. Or at least if we disconnect his alternator and see if that draw goes away, it will confirm that something's inside the alternator. And if I use the oscilloscope, we might be able to see a bad diode or something. Shorted, something shorted. 11:30 seconds or what?
No. Well, I'm kind of embarrassed to say anything.
Uh-oh. It's been remanufactured, it looks like, so you never know what you get.
I was embarrassed. I didn't want to say it was nothing. And making sure I keep everything in the same location. Break anything off of that. And when you guys are in the junkyards, always look for little things like that. Gold. Okay. Boy, that Dane had that tight. Right back there, you got me.
Actually, I think that was
Want more coffee,
14-year-old
Travis?
me.
What?
You want more coffee?
Yes, please.
Okay. Same way?
Yes.
Whatever that little one is.
That is the ground stud, if I remember correctly. Looks like a 5/16 socket. He's using the adjustable wrench instead of doing it the easy way. For some reason, this set skips the 5/16.
I have it off.
Oh, you have it? Already got it. So it must not have been very tight. 8mm will work though. Okay, so this is the alternator, suspect alternator out of the young man's truck. This is the temporary donor alternator out of the 1969 Bumpside. Looks like they are identical on the back. I don't know if the mounting is going to be the same, but they look basically the same. And since we have everything disconnected from the back of the alternator, may as well check that that draw is now gone. Real quick, just to confirm, now that we've removed the alternator, the suspect alternator from the 76 Dentside, I've got the test light connected to the battery positive cable. I did reconnect the fuse link back where it's supposed to go after we narrowed things down. The voltage regulator is plugged back in. Remember, we had a draw with the voltage regulator plugged in. And when I connect to the battery positive, notice there is no draw. No draw. So it looks like there's something inside that alternator that's causing a draw, young man. So we're going to, in a minute, after a quick coffee break, we're going to get the 1969 generator alternator installed on this truck and confirm that there is no further draw and confirm normal charging system operation. Like I said, we need to put that voltage regulator back where it belongs, where it is properly grounded. I think that having this not grounded is most likely why you have a boiling battery. This needs a ground reference for proper charging, okay? Because otherwise, what this is going to see is varying voltage, and it might not even see the proper battery voltage, and it's going to end up causing that alternator to way overproduce and boil that battery. Does that make sense? Okay.
Okay, I see that now.
That's the field. F for field. This one goes to the stator. And I think, did we have a ground? We had the little ground stud there.
And where's the ground now? Oh, that's that.
Yep.
Was there a separate ground cable?
Nope, it's built into the connector here. It's
Okay,
built into
that makes sense. Wrenches, please.
So we need
Just
a
grab those.
7/16.
Should be over there.
Let's see if that 8mm, because your set doesn't even have a 5/16 in it.
It's over there.
I didn't even see a place for it.
Here's a 7/16.
7/16 wrench.
Thank you. Not too tight. Put that back down there. Okay. So, this is slipped on tight. That is slipped on tight. I got it already tight. Okay, I'll do a little more. There.
Okay, and do we have a draw with this test alternator, which is not grounded to the block, but it is. Oh, look at that. No draw. Nothing. Okay.
Okay, so let's go ahead and
get it
where's the
installed.
spacer and the long bolt?
Spacer and long bolt.
1 second, check this ground cable down there. That's good. Should point that down a little bit more. Okay.
Get the top bolt first so it can just hang.
Oh boy, no anti-seize, huh? That damn good. Okay, spacer please, long bolt.
Here's the long bolt.
Oh, no anti-seize.
Spacer.
Hold on, let me get this, do the bracket first, please. Right, to the bracket. Taking my time, making sure I got it right. Double check the battery disconnected while I'm here. And while we're here, take a look at that. This clutch.
Oh, yeah. That's a problem.
That's a major problem. Especially, yeah, I can grab it and move it up and down a little bit too. 9/16 socket, please. Put that in the battery magnetic tray. Get this in here, get this back here. Where's that big crisp? Well, we don't need it too tight, do we?
Just a quick test run.
Pull tight now.
I am pulling tight.
Okay, that's it.
It's good enough for a quick test.
Okay.
Actually, that's a lot tighter than I thought I could get it. Okay, remove the tools from the top of the engine. Remove the tools from the top of the engine so it's safe to start up.
Let me take a double check seat and everything there. We got this snugged up, but nothing there. Got the spacer. I don't see nothing going over to the side. Okay, we're good.
Okay,
What was this
confirm.
hooked up to? The choke
That was to the automatic choke, which needs to be not connected with a alligator clip, and I'm pretty sure that it needs to be connected to an ignition source that is connected to the
Do you
ignition
want me
key.
to put a connector on it right now?
Well, we'll prescribe what we need
You
to
want me
do
to hook
later.
this back up?
Probably don't even need it because I think the engine's still warm, but
Yes.
may as well hook it up because then
The engine is still warm.
it'll self-open. And confirm again. Let me confirm again. No draw.
No gasket on the carburetor.
Actually, the light is lit, so what did we miss? Oh wait, disconnect that automatic choke. Does that make a difference?
Nope.
How come the light was off when we had the alternator not bolted to the block? How about disconnect the regulator? Okay, the light is off, so what are we missing here?
Is it ground at all through the block?
Yeah, the alternator will ground through the block. You need a jumper wire for that?
Here, I'm rubbing this all voltage regulator on ground.
Put it on the battery negative so you know it's a ground. Okay, so do we have something going on inside the truck with that ignition switch? The wiring schematics are they're laid out across like 5 or 6 different diagrams, and I don't have the ability to print them at this time, so it's really difficult to read them. And it looked like one of the wires, which one? The green and red wire. It looked like the green and red wire went inside of the cab.
What's this wire here too?
Looked like it went inside of the cab to the ammeter and a fuse, and it should be connected to the switch in some way, ignition switch. So
that there is.
all right, so evidently I need to do some brushing up on basic Ford external voltage regulated charging systems. Come on in here. This is the 1969. We are doing a little comparison. The voltage regulator is here. The green and red wire, same setup. I've got the voltmeter connected to ground. Turn the key on real quick. So as you can see, that light lights when the key's on. Turn it off. Now let's go look at the 76 Dentside and see what happens when we do that same test. Back over here on the 1976 Dentside, do a little self-test on my test light. Key's off, right?
Key's off.
Okay, same terminal. Turn the key on, and we get the same result. So, could this potentially be a faulty, brand new faulty voltage regulator? Or could this regulator have been destroyed because it is not grounded and it's been overcharging this whole time, and it's probably been having some serious voltage spikes? So now, okay, shut the key off.
Key off.
Okay, come on out here.
That would make sense because that would have been attached before we put the clip on
Yeah.
and took it off.
Yeah.
Put it on wrong, and then the draw occurred.
Perhaps. Okay, so we're rolling here. So now we're gonna come on over here and we're gonna swap the known good voltage regulator from the 1969 Bumpside over to this truck and see if that draw goes away. Or perhaps we could plug this one in to the 69 and see if there's magically a draw in the 69 now.
Okay, these are 3/8 lag type bolts here on the regulators. 2 of them. I would highly recommend making sure the battery's disconnected.
Uh-oh, it's broken
And
now.
Lordy B, I didn't know it was already unplugged.
Whoops. Let's hope it's still good, although, you know, it's a solid state voltage regulator. There's not really any moving parts inside of it. Not like the original ones. The original voltage regulators were mechanical. Okay, so this is the
adjustment screws on
suspect.
the inside too.
We're going to hold that there for a second because there's no alternator actually installed in this truck at this time. So we can't compare, but we can take this one over to the 76 Dentside and see if that makes a difference. Okay.
I'll bring the screws.
Over here on the 76, this is the known good voltage regulator. Going to plug that in. And do you have a jumper wire? We can ground this properly real quick, just to be
Just
sure.
take a second to install it.
Well, I don't know that this radiator
Okay.
core support is properly
I
grounded.
do
That's
have
the
a
problem.
jumper wire right here.
So I would rather use a jumper wire straight to the negative battery so we know it's grounded.
Minus negative.
One. Okay, and hold that. Where's my test light? I'm gonna do the old test light trick. And is it just me, or is there no draw?
Zero draw.
So I suppose that confirms that, young man, your brand new or newish voltage regulator is faulty. So that's one of the oldest lessons when you're working on cars, is that you never trust new parts. And I personally suspect that that voltage regulator was destroyed because it's not properly grounded. So I suppose if we properly install and ground the voltage regulator and start this truck up and do a quick little test, make sure everything's working properly, and confirm that that's what's going to fix the problem. And luckily these are what, 20 bucks? Cheap.
16 to 20 bucks.
Well, they used to be, I don't know.
Okay.
And you probably actually have an extra one around, floating around here, I'm sure. Or we've got that other truck up there, but that might be one of the original mechanical voltage regulators, and it's better to just replace them with the new solid state. Just confirming, he just bolted up that regulator, the known good regulator, to the core support, and there is no draw. No draw.
Show that. Wow.
Nothing, because the key is off. Okay. Now, we're going to hook this battery up real quick, start this vehicle, start the engine. Well, wait until I get my equipment in place.
I'm going to double check, make sure all tools and parts are out of the way.
Make sure that the truck is safe to start. And I'm going to get a lab scope recording of a known good charging system, and then we will put his old his alternator on, which I suspect is fine. His alternator is probably fine, but we're going to compare. I can compare the data after I take an oscilloscope measurement, and then, well, let me get my equipment set up, and then we will see about getting a new voltage regulator. We might have one in stock in town, right? What time is it?
It's 2:25, and you very well.
That's a very common part to have on the shelf. So brand new regulator might even be on the shelf, so we could fix this today. We'll see about that. Okay, give us a minute. So show us the Cave of Wonders thing you found in the Cave of Wonders. Show us the Cave of Wonders.
I always, when I go to junkyards, I always collect things like this, and this is a voltage regulator. And it's an Eklund. It's a Napa part. It's probably an expensive part there.
It's a little rusty on the back, so I think we're going to prefer to put a new one on.
Yeah.
Okay, young man is sitting in the truck. We are not standing in front of it because you never know what's going to happen. It is in neutral, yes?
Yeah.
Okay, go ahead and start it up. Okay, turn the headlights on.
Headlights on when it's running. Start it up.
Yeah, turn it on. To start it up, put the headlights on. Just put a little load on it. Get that voltmeter. Yeah, not running very well, so keep an eye out for the tune-up video. We're going to deal with that. We need to add a PCV valve and do a little tune-up.
My choke plugged in?
No.
No. Okay.
So that could be a lot of the problem, but again, this choke does need to be changed up.
Which one's negative over here on the post?
That one. So I want to see that it is actually charging without having to look at the oscilloscope. Because it looked like, when I looked at the oscilloscope, it looked like it wasn't even charging, but I don't know.
Here, right here to the cable cord right there. Hook it into that clamp if you want. Okay.
Okay, go ahead.
Clear.
Give it some RPM. Rev it up a little, need RPM.
You'll rev it up to about 1,000
Choke, I don't think that choke is operating.
I'd give it a second to open it.
Hold the pedal to the floor and then start it. It's probably flooded. There we go. Okay, so we are charging. And I'm collecting the oscilloscope waveform there. Okay, turn your lights off.
Lights off.
Alright, they are going to run down to the parts store and see about getting that new faulty voltage regulator warranted, although I think that it failed due to the not being grounded. But if they can warranty it for free, great. Otherwise, it's like $56 for a new one. And they will be back in a minute. We'll probably put a new one on if they pick a new one up, and this one's going to be fixed. I did tell him to if he leaves this connected to the automatic choke, it's going to also kill the battery, so this needs to be properly wired in. And this is not the picoscope that I am accustomed to, so I don't really like the zoom feature on this, and I don't have enough practice messing around with this lab scope, so you know, I just mess things up. So I don't know, I think I'm going to give up on the idea of doing the oscilloscope capture today. I need more practice using this scope. I don't use this very often. Alright, show off your new toy. That's the bad one going back in the box. You might want to warranty that later, now that you got a receipt, right? That's the new one. Oh, you got a receipt for this one you just bought, right?
Nope.
What?
I don't do those.
Always get a receipt every time.
They know me down there.
Well,
I walked in and he goes, I knew it was going to be you.
they know you until you want money from them, and then it's like, who are you? Okay, so this is the new one. Just pull it off. Okay, you go ahead and put that one back on the flatbed, 1969 flatbed. Young man here is going to install his new voltage regulator over here, and we will do a quick operational test, and then we'll be swapping the alternators back between the two engines.
And then test again.
Yep.
Perfect.
Okay, nice. Alright, young man, just installed the new voltage regulator, and I said, yeah, let's do the quick confirmation, and I was like, look, the light's lit, we still got a draw, what's going on? Well, come on in here, young man. What did I tell you about this automatic choke? Can you see the test light as well? Okay, so I'm going to disconnect his automatic choke, and look at that. So does that prove to you that you need to rewire this automatic choke properly?
Yep.
So now when you park your truck, you need to at least disconnect this automatic choke every time. So this is supposed to be wired to a key on source. Okay, so at first I was losing my mind. At first I was losing my mind a little bit because I thought, well, we still have a draw, and I was like, how could this be possible when we had no draw with his regulator, but we have a draw with this brand new regulator? No, it's not the case. The new regulator did fix the problem, but we just need to rewire that automatic choke. Before we swap the alternators back, we're going to do a quick operational test. Okay, it's in neutral. Go ahead and start it. Look at that. Give it some RPM. Yep. We've got the headlights on. Okay, shut her down. Shut her down. Alright, we're going to swap the alternators back. Young man, make sure you disconnect the battery first. I prefer to disconnect the battery negative, and there is actually a safety aspect reason for that. Because if I had my tool, and well, if you disconnect the battery positive, whatever, it does work. But if you had a tool and you accidentally touched ground while you were touching positive, you would have a little zap. I had my wedding ring melt to my finger before by doing that, so I learned that lesson. Always disconnect the negative battery terminal first. So he's going to do that. He's going to take this alternator off, which came from the 1969, and we're going to put it back on the 1969. We're going to put his alternator back onto his truck and then confirm the operation, and we're going to be done for the day. And doctor's orders is that we need to install some fuses on these add-on wires, which was for your cell phone charger and the roof lights, or what?
Yes.
Okay, so we got roof lights and cell phone charger, which theoretically you could wire the roof lights to your headlight switch. You know, you could wire that up properly, but I'll let you worry about that. So you need to add some fuses to these wires. And this one, I think you said, was for a Dixie horn.
This one is for the cell phone charger. The little tiny crimped one is for the cab lights.
I see 3 here.
This is either for the Dixie horn.
Either way, any of these little B plus leads that you put on battery power need to have a fuse within 12 to 6 inches of the connection point to prevent burning wires through sheet metal or whatever, wherever you pass them through. So you need to do that. You need to rewire the automatic choke properly so that it won't kill the battery after we're all done here. And he asked me, he said, where do you recommend plugging it in? I said, well, let's take a look at the wiring schematic and see where is it actually supposed to be wired up, and potentially we could wire it to the positive side of the ignition coil if there is no ignition resistor or whatever, but I'm going to do the research real quick while they swap over these alternators. I don't think we need to really show that. It's pretty simple.
So reinstalling this voltage regulator, I noticed that my lag bolts that are stripped out, plus I lost one in the gravel, but bottom one stripped out, so I'm going to go ahead and put a 1/4 in there with a lock washer and a new nut.
And we're going to find that other one with a tire later.
Yes, it's going to be at someone else's tire.
Yeah. Okay, so I'm going to go do some research while you guys swap parts back over.
Okay.
Quick tip here.
So, I can't get my normal size fat hand down here to hold the lock. I put the lock washer and nut on this voltage regulator retaining screw bolt here. So I tried I magnetized this right here. This just always saves my life on these. Magnetizing it. These are the little hose clamp ones they have at various stores, cheap. Get that in there. Oh, come on, baby. Okay, let's go down in there. And it went on. Yes! So now I have to do this one from the back side too. And I will be turning it with my ratchet on the other side. Get that started. Get that first. All right, it's going through. Got it. Yeah, I could use my air tools. I could use a whole bunch of variety of tools, but I like turning the wrenches.
All right, we've got the alternator back on this truck. This is the one that came out of this truck. It is back on the truck. We've given him some inline fuses to properly wire his add-on accessories, and we will be dealing with the electric choke thing later. Okay, go ahead and start it up. Let's confirm it is charging. There you go. Perfect.
I want to check the timing before you go anywhere.
Okay, so he wants to check the ignition timing, but that's going to be on a different video. We'll do the tune-up video. We told him we're going to do the PCV valve, install the PCV valve. I would change the oil before we do any adjustments to the carburetor because I'm sure that the oil is full of fuel and moisture, and that's going to make a big difference on your fuel mixture adjustments. And we're going to wrap it up from here.
Yep, go ahead. We're checking the timing. It's a preliminary.
Be careful of that fan.
Well, I have no markings on there. I can't see nothing. We'll have to come back to it.
We'll come back to it. Keep an eye out for the tune-up video. Okay, this is the outro, the summary of what we did today. This is the 1976 Dentside Ford. We had a key off battery draw, draining the battery 1.8 amps, which will kill your battery in a few hours, if not overnight. It'll definitely kill it overnight. And you said you had to disconnect the battery basically every time you parked it, right?
Yep.
Okay, so you had the new voltage regulator on there, but it was not grounded. I think that was the entire problem, that the voltage regulator was not grounded, which caused the new voltage regulator to fail internally and cause your battery drain, battery draw. We swapped alternators after doing some testing. We swapped alternators from the 1969 Bumpside Ford, and we still had a draw, and we swapped voltage regulators to confirm that it was indeed the voltage regulator. I did a quick comparison of the wiring on the S terminal of the voltage regulator. We had the exact same conditions, key on, etc., between the two trucks. You know, the 69 Ford, which is known good, has a good charging system, does not have a battery drain problem, and everything tested the same on this truck, thus confirming the faulty voltage regulator. So I hope somebody learned something today. I hope you learned don't ever trust new parts, right?
Yep.
That's just like a repeating lesson in some of my videos. Don't ever trust a new part. Ford externally regulated charging systems are some of the best to learn charging systems on. They're so simple, and they're interchangeable from truck to truck to truck for like decades. They use the same setup, and if you understand a Ford externally regulated charging system, then you basically understand all charging systems, even modern charging systems that almost work identical to the old stuff. Okay, so that's really all I've got today. So thanks for watching. If you watched up to this point, hopefully you learned something. Thanks, bye.
Okay, let me move the light out of the way for you.